Chapter 3, Quadratic Equation, Part 4, the nature of the root of a quadratic equations. In this video, I would like to introduce the application of the nature of root, or introduce what is the minimal nature of root of a quadratic equations. Nature of root, that means I want to determine whether the root of a quadratic equations are real or not. I want to use the following example to illustrate how many cases do we have of the quadratic equations. Case 1, if I want to solve x squared plus 3x plus 2 is equal to 0 by using quadratic formula, and it is not very difficult to find because x is equal to negative b plus or minus square root b squared minus 4ac over 2a. So in this case, we have two distinct root. We have two distinct root. Or sometimes we'll call we have two unequal root. Second case, I want to solve this quadratic equation by using quadratic formula. By using a quadratic formula, negative 4 plus or minus square root 4 squared minus 4 times 1 times 4 over 2. 4 squared minus 4 times 4 is equal to 0. Root 0 is equal to 0. So negative 4 plus 0 or negative 4 minus 0 are equal. So we have two equal roots. In this case, we have two equal roots. So the last case, case 3. If we solve it by using quadratic formula, negative 2 plus or minus square root 2 squared minus 4 times 1 times 3 over 2. If you simplify the value inside the square root, which is equal to negative 8, so that in this case, we cannot find any real root because root negative 8 is undefined, no real roots. So you can see I have already demonstrated three examples, three different cases, which is the first one is two distinct real root, the second one is two equal real root, the last one is no real root. But which term is the crucial term or very important term to determine the nature of root? I mean, these three cases you can see, which is depends on the term inside the square root. If this term is equal to 0, that means plus or minus square root 0 are equal, the values of x are equal, so that in this case we have two equal root. And then if this term is greater than 0, that means we can find the values after taking the square root, so we have two distinct real roots. If this term is more than 0, then I cannot find any real root because this is square root a negative number. So I would like to introduce one important term which is called discriminant. We'll use delta to represent this part because I can make good use of this part to determine the nature of root. B squared minus 4ac, this is the term inside the square root. If I find delta is greater than 0, imply that we have two distinct real root. Delta is equal to 0. One double real root or two equal real root. Delta is smaller than 0. No real roots. Let's see example 3.12. Given that the quadratic equations, these equations has two equal real roots. What's the meaning? That means I know it is because two equal real roots. I can know the values of delta. Delta is equal to 0. What's the meaning about delta? Delta is b squared. In this example, a is equal to 1, b is equal to k, c is equal to, remember, is negative k. So k squared minus 4 times a times negative k is equal to 0. K squared plus 4k is equal to 0. Sorry, one typo. Help me to change it. K is a non-negative integer. Non-negative integers. So when you solve it, k is equal to 0 or k is equal to negative 4. So reject this one. K is equal to 0. Then part B asks you to find the root of the quadratic equations when k is equal to 0. X squared is equal to 0. X is equal to 0. Repeated. Try to do example 11, for example 11, and pause the video and I will show the answer to you. For exercise 11, the quadratic equations has two distinct roots. Ask you to find the range of the values of k. And several things I want to emphasize. First, in these questions, the x coefficient is equal to x squared. The coefficient of x squared is equal to k. So a is equal to k, and b is equal to 7, c is equal to 1. Second, what is the meaning of find the range of the values of k? That means you cannot find the exact values of k. You can only find the range. That means your answer must be in. You need to represent your answer by using inequality sign. Okay, so this quadratic equation has two distinct real roots. That means delta is greater than 0. B squared minus 4 times A times C is greater than 0. So plus 4k on both sides, and then divide 4 on both sides. You can find the answer. K is smaller than 49 over 4. When k is the largest integer in the range, find in A. So k must be less than 49 over 4, and k is the largest integer, so k is equal to 12. Substitute back to the equations, and then factorize it. 3x plus 1 times 4x plus 1. I know two terms multiplied together is equal to 0. Either one of them are equal to 0. So x is equal to negative 1 over 4, and 3 and over negative 1 over 4. Finish. You may try to do exercise 3D question 1, 2, 11, and 12. We can have more discussions on how to apply the nature of wood to solve different kind of questions.